All right, so hi everybody. Folks, you had a great lunch. My name is Juni, and I'm going to talk about continuous delivery pipeline, some patterns and some anti-patterns that have been noted in the industry in the last almost like a decade. And the initial part of the talk, which would be like domain-driven design, which is popularly called DDD. These are concepts authored by Eric Evans. I'm very grateful for all the great work that he has done. So when I went through DDD, my first thought was, why not apply DDD to continuous delivery? And I brought it up like to my coworkers, and they were like, okay, why not? Because nobody else seemed to have done it, so it doesn't hurt if one person goes and does it, and even if it doesn't work out, why? I mean, it's still a valid experiment, and we'll definitely learn something out of it. So there was pretty much an experiment, and I wanted to bring the thoughts to you to see if this is something worth doing. Domain-driven design is pretty standard, and doesn't hurt to see how it applies to the pipeline. So, and this is like a fat book. By no means can I do the topic any justice in 45 minutes, but I'm going to try and bring the best of whatever I learned to you, and then see how it goes. So there are some basic building blocks: entities and value objects, aggregates, the domain itself, the model, the domain events, and ubiquitous language, and the services. So what I decided to do was focus on primarily these 8, and then if you would be even more interested, there are like a lot of literature behind these. So when we say entities, it's defined by an ID. It's not defined by its attributes. So something like the pipeline, if you get the build number as an identification, then that's something like your identity. The value objects, on the contrary, are defined by their attributes, not necessarily their ID. So if you're looking at test execution results, so it's defined by the attribute like status, like did the test pass, did the test fail, how long did the test take, so something like duration, in which case you see it's something defined by more like the attributes and not necessarily by an identifier. An aggregate is a collection of objects. I guess the pipeline is indeed a collection of several objects. This we will definitely see later in the presentation. The domain is what we are studying. I'm saying the domain is continuous delivery in our particular case, in this particular session. It's a sphere of activity. It's a sphere of knowledge. Some people say it's a sphere of influence. I'm good either way. I'm not trying to beat the definitions to death, but generally, like, we'll try to understand the concepts. The model is a system of abstractions. This we'll do a deep dive on a little bit later. Like, we'll model the pipeline. By pipeline, when I say continuous delivery, I mean we are going all the way from source to production, so all the way from left to right as we know it, and we'll try to model a pipeline and see like what it really entails. And domain events, this is probably a very simple concept, the events that the domain experts care about. So if you're saying, hey, I did milestone 1, whatever, like check-in to dev, check-in to stage, check-in to prod, these are all milestones that we care for as engineers, as engineering managers, as architects, as the C-suite, your product officer, your information officer, everybody cares for these milestones, like how you're doing it. And these are events that the domain experts care for. So I'm just going to imagine myself as the expert. So if how the pipeline is progressing is something that I definitely care about. The ubiquitous language is shared language. This brings all the teams together. So how many times have I sat through meetings where I think we are all saying the same thing, except we are using a different term for it, and we are just kind of losing each other in that process. When I say module, you meant tier, and somebody meant component, and then somebody was actually thinking subsystems. So I think we were all on the same page, except it took the first half an hour of that meeting to understand that we are actually on the same page. So there was really no need for the first 30 minutes of the arguments. And domain services are like shared functionality. So this has come up in Jesse's, the talk that preceded mine. came up several times, and I'm also going to go into it a little more, but this is still, Jesse is like the domain expert for this particular. I would still go back to Jesse's talk and figure out how to implement domain services as part of the pipeline. So with that, so we'll do how to maintain integrity in that model. So let's say the first thing that DDD asks is a bounded context. So bound the context with means have a bounded context so that you know what you are dealing with. This applies to everything, not just continuous delivery. But then we'll also see something that is very key to continuous delivery, like the model tends to fragment. And it's okay to accept fragmented models. Like even if your leader says standardize the entire company to use a unique model, it's probably going to be very hard. So it's okay to have fragmentation, just not too much of it. And so try to stay between the boundaries of fragmentation, and we'll see one such example. So, I mean, it's not possible to read everything, but I'll see like if I can open a bigger picture of this. So this is the pipeline as code. Like let's just say this is the Jenkins file, and you see the whole pipeline process happening, like unit test, static analysis, first the linting, then understanding if there are security vulnerabilities in the code, building and publishing versioned artifacts, deploying to some sort of a dev environment, and you see the evaluation happening at the end of every step and a decision point whether to go forward or not. So if you're not going forward, you just come back up and ground yourself. Or if you are going forward, then you just keep going and go to the next step, which is you can run functional tests and performance tests in a dev environment in parallel. We'll also look at the parallel syntaxes. So at the back of my mind is to connect the implementation to this evolving model. So we'll also look at Jenkins 2.0, pipeline as code, Jenkins file as we go. And that is why I say the talk preceding mine was very key. Jesse actually went into details of these particular things. And I would definitely go back and watch that video again. So then if you check if it's your master branch, so let's say this is your develop branch where you have a little more freedom to make mistakes, but when you go into master, you're mentally prepared to see yourself go live in production, which means you're going for your customers now. So little more caution. Some companies may require you to create a change request at this stage. So this is not to gate you, not to slow you down, but to leave an audit trail so that if something does happen in production, you can always come back and take a quick look and see what happened, who did this change, and etc. There are many other ways to actually have traceability, but change requests are legacy, and they are required by some auditors. So if you are required, it's okay to do it through the pipeline. And Jira allows you to do like REST calls so easily, so it's not really a problem. So the other thing is, on the left you will see all the tools that are mentioned, and here is what I meant by fragmentation. So there is a Node, there is a Java pipeline, there's RDBMS, there's Android, there's iOS. We actually had good conversations on Android, Java's, Nodes. I didn't quite see RDBMS, at least not in this session, not in this conference, but this can also be a very lively conversation given all the sorrow that it brings to continuous delivery. Like databases haven't really been like the favorite topic of many people, and the entire concept of DBAs, the whole thing. And I'm not going to go into it in this session. It's not a topic. It's actually a topic in itself. So it could be like a whole new talk altogether. So the other thing is, so keep going down the line. So you keep evaluating, and pipeline can poll to see if your change request was approved. So it's okay to have one manual gate because a lot of companies do not allow you to go headless end to end. And I mean, I'm not going to fight that battle right now, but let's say if it is indeed right, then have the pipeline poll, it's okay. And then once the change request is approved, run functional performance security, and security like a big thumbs up for it. This is where you do not leave InfoSec to come in at the end of the pipeline, do a pen testing, and then like slow you down, right? It's already built into your pipeline, so you would know if you're writing insecure code. And then off you go. This is entirely a check-in to go live, and this is what I meant by domain events, like check into dev, check into stage, check into prod, or check into go live, however you want to. So this is what I meant. If you have to allow fragmentation for Node, for Java, for RDBMS, for Android, iOS, and you may have the Rubies and the Perls and the Pythons, that's okay, because you'll see the treatment for each different pipeline can be a little bit different. Going back, so this is where we are. So this is where we mean by there's a blur, some of the edges will blur. So bounded context can be within one vertical, but here we introduced the concept of context map, which is like it maps the entire terrain. So your company can have maybe like, Node, Ruby, and Java, and in which case, and maybe iOS, Android, and a database. So in which case, that's your terrain. So you had a bounded context, you allowed it to fragment, but now you have a context map. So if we are okay till here, and you see whenever we finish something, we'll actually finish with flying colors, hopefully. And we roll the dice again, and this time we come to ubiquitous language. Ubiquitous language is something that gets us on the same page. Business and technology can all talk the same language and not have a fight. Components, subsystems, and systems is how I'm trying to go to like model a pipeline. So component is the smallest distributable and testable units. Subsystem is the smallest deployable and runnable unit. And subsystems are loosely coupled components. And then systems are loosely coupled subsystems. So we'll try to model saying components, subsystems, and systems. So that's essentially what all of us are trying to do one way or the other. So when we say components need to be certified, we say unit test, static analysis, linter, static analysis, like security vulnerabilities. When we certify subsystems, we say functional, like security, ITNN, LTNN, a lot of things here, and then performance. And then when we do system, we typically focus on integration, but rather more on interfaces, network, and then performance. So components are the modules, libraries, like imagine these could be like Java, like if you're a Java shop, these are the jars, the libraries. And the subsystems, they are all, so these could be like the jars. Now, a lot of smaller jars got assembled into larger jars probably, and the IPAs and the APKs in case of iOS and Android. And then I'm going to touch a little bit on IoT towards the end. So if you're thinking about those things in the Internet of Things, the things are very expensive. So if you have to test with the mobile phones and the devices like cameras and worst case traffic signals and washing machines, like hopefully not all of us have to do it on a daily basis. But if you did, you'll understand that you'd rather use emulators and simulators at this phase rather than try and get one of those devices to have your subsystem certified. You don't want to get slowed down so early in the pipeline. At the same time, this cannot be the certification criteria for production. So when you're certifying your system, you would actually need everything, all the real devices, and not just them, the accessories that go with them too. So we'll come to that a little bit later in the presentation, hopefully. So more balloons for us. We're trying to go a little fast, but we can always come back for questions. And then roll the dice, we go to continuous integration. So this is probably my favorite in all the domain model integrity. So this is like continuous delivery pipeline, continuous integration for the continuous delivery pipeline. So how cool is that? So pipeline is a product. So there are two things. There is a pipeline, and there is a product flowing through the pipeline. So the product flowing through the pipeline is the one we are trying to certify, which is all good. But what about the pipeline? The pipeline is a product, right? It's a production asset. When the pipeline goes down, we have no hope for the product going through the pipeline. Like product going through the pipeline will suffer if the pipeline is not treated as a first-class citizen. So this is continuous integration, continuous delivery for the continuous delivery pipeline itself. But having said that, what do we mean by the continuous delivery pipeline? We mean the product, like I said, the product that's flowing through the pipeline. We mean the tests that are used to certify that product flowing through the pipeline. We say SUT, which is the system under test. and the tests themselves, there's configuration, not just for application, there's configuration for the environment. Then we have infrastructure, which is infrastructure as code, of course, and this was a very good presentation yesterday by Tyler, who made sure that we treat infrastructure as first-class citizens, write tests, etc. And then we have the pipeline as code, which is Dockerized Jenkins 2.0, let's say, and it's a particular example. Jenkins in a container, we have Jenkins file, which is the process as code, and we have the shared kernel. Let's say there's a utils.groovy, but I would, again, like look at the at library and at grab, which Jesse mentioned. I think that would fit in right here. And then let's look at this model a little bit in detail. So this is the whole model. So when I say we go all the way from left to right, this is like going from the source, all the feature branches. This is a pre-commit phase, where we first go into a branch where all the team meets. And when we say there are components getting certified, there are tests, there are foundations. This is a lot where Tyler's stuff would probably come in. Maybe if you're managing the chef cookbooks and recipes, maybe you have a chef pipeline just as much as the product. You go into a develop branch where the team's code comes together. You go to pre-master commit. Master is where the entire company comes together. So you're like kind of making slow progress. We definitely want to go to production, but we don't want to rush there. So we want speed, but we don't want suicidal speed. Like we want responsible speed. So we go pre-develop commit phase. We go to subsystems. This is where the subsystems get certified. Subsystem, if you remember, is the smallest deployable and runnable unit. And these are the components, which is the smallest distributable and testable unit. In which case, once you're here, once you're going to master the pipeline, you actually are ready to see yourself in production. So all the good stuff, publish your artifacts, noxious artifact tree doesn't matter. Noxious by no means that it has to be noxious. Chef doesn't mean that is how you're managing configuration, however you are. If you're Dockerized, great. Jira, if you're still having to file change requests, and then you do subsystems, the certification comes with functional performance security. There are automated gates here. So you don't have a human gating you. You have you gating you with automation. And it's not like, your auditor may ask, so do you have like infinite access? Well, you don't. You gate yourself with tests which are agreed upon. And this is something that today's keynote brought up, like segregation of duties doesn't mean human being B can say human being A is right, or human being A can say human being B is right. That's not what segregation means. Segregation means you gate yourself with a test, and the test is your code is your documentation, and it's agreed upon by your auditors, and everybody signed off on it. That's how you gate yourself. And then there are some stop signs for system because you don't want to couple too much. You don't want to tie all the subsystems up at their hips so that the fastest subsystem will be slowed down by the slowest subsystem. That's not what we are trying to do here. So, but then we have a lot of legacy. So sometimes this is what we have to do to go to production. And then when you are in production, we are all familiar with the blue-green. You are on green, and this is where dark launches come in. You move the bits, you do not turn them on. These are two separate things. So once you have the bits, you don't have, let's say, you run your test only when you're comfortable. You start routing your users to green. Till then, they were all on blue, happily. And then once you're confident, you have A/B tests. This is super key. You have the ability to say your product owner would love this piece. Like the ability to say that if A or B, like I can test two configurations at the same time. And then business metrics tell me if I should go live with B and not A. And then off you go. So B goes live. So this is where we were when we said, coming back, this is the continuous delivery pipeline. We have to maintain the integrity with continuous integration. And then value stream map is something that's being thought about in recent times. So this whole pipeline, even when you see the stage view of pipeline, you actually see value streams. You see the value adding stuff, and you don't see the non-value adding stuff in there, hopefully. because that's what a value stream maps asks you to do, like focus on the value adding piece. So this is a quick follow-up on slice over dice. So you'll have the conversation several times in your company, like I'm trying to build a minimum viable product. How should I do it? Like where should I start from? Some people will say, go breadth first, right? Like go along the green lines and then keep going till you cover your entire product stack. The other school of thought is go blue, keep going, keep going, keep going, and then ultimately you'll cover the stack. You can cover the stack either way. My recommendation would still be to do slice over dice, which is green over blue, which is go all the way. This is true continuous delivery if you go all the way, and then the learnings are the highest if you go all the way instead of going one dice at a time. There's no harm. I think at the end state is still the same, but in my experience, slicing has given better results to the teams than dicing, but the decision is of course up to you. More balloons. We kind of have some idea about continuous integration for the continuous delivery pipeline. Now going to look at a big ball of mud. I think you started talking about it with my stop signs. So subsystem 1, 2, 3, 4, all the way to N, all being assembled as one system that goes out all at once. So it's like either we all go or none of us go. That sometimes doesn't really work at all because the fastest team needs to go first. You don't need them to wait for the slowest team to catch up. That's all about velocity. That's all about productivity. So the more tightly coupled your product architecture is, the least benefits you'll have of your pipelines. Even if you have built something, but then at the very end you're all tied at your hips for success, it's going to slow you down. This was also a theme in today's keynote, if you remember. There were 2 specific slides for tightly coupled and loosely coupled. And the tightly coupled, you get a graphical pattern in your pipeline. And tying back, if you did have blue ocean, you'll kind of recognize the graphical pattern. It's not too hard if you had something like blue ocean. Whereas I'm going to do, so separate ways. Now, what we want to do is we want to free the teams up to go their separate ways, which means the fastest team can try and go fast if they wanted to. In which case, we should shoot for linear patterns, not graphical patterns. So if you did have blue ocean, or even if the simple stage view would easily reveal if you have like a linear pattern, which is these are the components, the certification happens, unit test, static analysis, and then deployments. You certify your subsystem, go to subsystem, the blue-green, and then launch your subsystem. So what you're not doing here is you're not trying to assemble into one single system, which try to mentally imagine you have UI, maybe a node, you have like Java middleware, you have an Oracle database, all trying to go together, or nobody can go. That pattern is what we are trying to avoid with a linear pipeline. And the pipeline will merely reflect your product architecture. So the real thing is to go back and look at your product architecture and then let your pipeline be more linear than graphical. So for test architecture, so imagine you have a producer. So we are now getting into how should we not have a big end-to-end kind of highly integrated environment at the end, right? So let's say you have a producer, you have a consumer. You have unit test, static code analysis for all your services, no surprises there. Component testing comes in when you don't have to go with the real consumer or the real backing system. So you kind of mock like a test double of your consumer, and then you have an in-memory backing store. So you do component tests with them, you avoid gateway integration across the boundary, you avoid persistence integration across the boundary, and then see how much you can do with the test double and the backing store. So this would obviously require to have great contracts and then honor the contracts. You can't let go of the contracts the moment pressure comes in. So this is where I think the biggest bang for the buck is. If you have good contracts, you don't necessarily have to rely on the real services. which is where we take a look at something called the customer supplier teams. So this is a very popular DDD concept, which says if you had a producer pipeline coming in, and if you had a consumer pipeline coming in, you will, if the test between producer and consumer means if you fail the contract. So let's assume something. So let's say the consumer drives the contract. When can the consumer drive the contract? When the producer is aware of all the consumers. So this is like the intranet model, which is I'm aware, if I'm the producer, I'm aware of who my consumers are. So my consumer can drive the contracting with me. However, when the contract fails, neither the producer goes to production nor does the consumer. So we kind of say, okay, everybody go back, fix yourself, come back and try the contract again. So this is not decision driven by the engineering team. This is more a decision driven by product along with engineering. So decide what your business needs you to do. This is not like, okay, I don't want to take care of my consumers. There are too many consumers. There's too much trouble. They write too many contracts for me. It's not up to the producer to decide this. Because typically, you will find us breaking free, trying to break free. But this is not opinions. These are like business facts. If you are tied at your hips for success, then that's what it is. Again, you go back to your architect and say, why did we build? Why can't we have business capabilities which are independently deployable artifacts? That's the question to ask your architect. And the pipeline simply, like I said, has to mirror your business needs. So the other thing to look at is a conformist. This is the exact opposite of customer supplier teams. So what conformist does is you again have a producer pipeline, you again have a consumer pipeline, but this time you're saying the consumer has to conform to the producer. That's the business requirement, which means the producer can break the consumer and go to production. So this is a producer is driving the contract. Internet model, the producer in this particular case may not even be aware of all their consumers. So I'm a producer, I write the contract, I give it to all my consumers. If some of them broke, I can't stop myself, I don't even know them, I still go to production. Consumers go back and fix and come back. And that's my running model. So that's just how it works. So again, this is a business decision. It's business and engineering. This is not solely an engineering decision. Shared kernel, this is going back to the domain services. So there are shared pieces in the pipeline that we need to refactor out. Again, you see this conversation happening a lot in the Jenkins file discussions too. Jenkins file tends to become like a kitchen sink at some point. You want to refactor pieces out, make them libraries, and then at library, add grab, again, like Jesse Glick. So one more look at shared kernel. So let's say this is your pipeline, right? This is your pipeline as code. You have a happy engineer. You have a customer who wants to shower you with love and money. And then all you have to go is from left to right, right? It's really straightforward. But how many times does it happen in 45 minutes as it should? So dashboards, source code metrics, build servers, artifact repositories, the environment, mobile devices sometimes Cloud Foundry, sometimes AWS. You have the configuration server, you have the change management server, and the pipeline keeps going back and forth, back and forth, back and forth. And all we are trying to do is, by the way, go from left to right. We keep going up and down, up and down, up and down. So what is it that we need to do better? First, maybe go look at the data center topology and see if there is a network latency that is being caused because half my assets are in the East Coast, the remaining half is in the West Coast. So you don't want to go back and forth, back and forth, back and forth from East Coast to West Coast for nothing. I mean, there may be a valid reason that you cannot absolutely bypass, but it's a good thing to look at, right? Sit with your network architect and look at it. The other thing is, if you're having a constant failure, like let's say I ran my source code quality metrics and I'm trying to put them in the persistent store, the database, and every time I get a failure, just have circuit breakers that would automatically detect that this line is broken, and it's not the most important thing for you to go to production, so that it's not even worth it stopping you from going to production. Let it go. have something on the behind, like that is not visible to the main pipeline, and then break the circuit, and then and it self-heals, right? When it's fixed, it comes back up and just fixes itself. So now your circuits are like, oh, I have connectivity back, and then I just keep doing like nothing happened. So understand the horizontal flow, and don't slow yourself down by a lot of the vertical flows not going very well. And in this very context, the Pubsub pattern has served us pretty well. You have like several internal pipelines, trying to communicate with each other, communicating with systems like the dashboard, like you're maybe trying to do some analytics. Try like a broker, like a topic-based Pubsub maybe, and then the topics are like, let's say this guy publishes topic A, when it reaches here, this guy publishes topic B. This listens to like A, B, and C could be coming from an external pipeline even, not even within my company's domain. So it happens all the time that I did an acquisition. Now I've been asked to kind of tie it all in. It's not easy. You can just say tie it all in, but it takes years. It actually takes years to tie it all in. But if you had like inter-system communication that is reliable, it's probably less of a problem than if you were actually going one by one. And analytics is an important phase. So if you had good publishers and good subscribers, and let's say you had a good topic model, and this is just pseudo, like let's say you identified exactly what you want to publish, what you want to hear, what you want to listen for, you could do amazing sets of analytics, which is something that is after the event. Like you could study it and make informed decisions for the next year. Like what is it, okay, if I have $1 million to spend next year, what is the biggest priority for me? Looking at analytics is data driven, and it's not based on anybody's opinion that I think this is what we should spend $1 million on. More balloons, anti-corruption layer should be really quick. So this is building on the domain services. This is just one quick example. So let's say you have log to dashboard as one of those services, right? This is like refactoring out from your Jenkins file. All your Jenkins file, all your pipelines need to do log to dashboard. Now what if this was Sumo Logic today? So they said, oh, just give us the endpoint and the message. So you did. 6 months later, they say, oh, we changed to Elk Stash. Sumo is too expensive. What do? Well, you define sharp interfaces. You don't let the teams down because you want to move from Sumo to Elk. The interface is still log to dashboard. It should be transparent to the Scrum teams. You don't want to slow them down just because you're moving from, let's say, even in the artifact repository, you move from Nexus to artifact tree. But if it's publish artifact, which is I give you an artifact ID, I give you an endpoint, deploy my artifact, I give you an artifact ID, I give you the environment, right? Manage the change request. I give you the change request ID. I give you an environment, an endpoint, which could be Jira today, something else tomorrow. Just don't let the Scrum teams down. Have a ACL, the anti-corruption layer, so that they are protected. The pipeline's velocity is maintained. And then, of course, you continuously do improvements behind the scenes. This is the last one. This is OpenHost, the published language. So no presentation is complete without the master's words. The change is constant, adapt you must. Now, what does it really mean? And my first shot at poetry, I'll try this on you and see how this goes. Unmanageable freestyle jobs you've become. You know what I'm talking about, right? Job, 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 job. So unmanageable freestyle jobs you've become, pipeline you must be. Declarative, versioned, and ephemeral become you must, or the dark side won't set you free. Pipeline analytics report you must, in the groove you must get. Make happy our engineers you must, don't make them fret. So this is basically the evolution, the revolution, and the keynote speaker or somebody else called it Renaissance. So may the butler be with you. This is groovy. This is it. So why groovy? I mean, there are like meeting after meeting going on. Why groovy? Oh God, I have all this. How do I go here? And what if they change it again next year? Well, tools will evolve. So calm you shall keep and carry on you must. Like we can't say the tools are changing on me every 6 to 9 months, so off I go. I'm not going to do CI/CD anymore in my entire life again. It's not that frustrating, but I also understand I've been through several of these changes year after year for many years now. The design is changing for the greater good of mankind. We are at the receiving end. It's not a very happy place to be at the receiving end, but at the same time, we adapt to change and we move on. I'm not really this is like go to Jesse's talk. So we have DSL, we have the ones that are serving us very well are the ones I'm calling out. Node is great, stage, great. Please have a timeout if you're asking for input. The input is great if you do not have permission to go headless end to end. This is likely going to be the case if you're a large enterprise. Please time yourself out if nobody is responding. Don't waste the cycles. Stage has served us really well, even in this views. Functional performance security, if you want to do in parallel, this is probably a personal favorite. It's reduced a lot of time. And then Slacks and notifications, everything has become simpler. However, I would still call the plumber. It's probably a discussion later today. I would rather have declarations than script, than code. And I think that's the direction anyways without me having to say it. So another conversation maybe down the line. More domain services, libraries, and the grabs. So this is quick. We talked about Sumo Logic being the dashboard of choice or Sauce Labs being where your functional tests are running. So sauceutils.groovy or sumoutils.groovy or the jars maybe as per Jesse. So include them, use them. These are the shared resources within the pipelines. DDD would just call them domain services or maybe shared kernel. Jenkins file, classy versus scripty. Many meetings are being spent on this. So if you really like the Java style, then yes, have them all in services directory, import them, call them just like Java. It's totally fine. And if you're going the library grab way, it's fine. But understand that the Jenkins file just cannot go on and on and on. It becomes too long. It becomes unmaintainable, and it's probably not the best long-term end state. Okay, so we are pretty much done. We have all the balloons that we could possibly get today. And I have a few minutes to actually do a concept called concept to cache. So we have the people giving us approvals, giving us money. Then we have the inception sessions. We have tooling, we have security, we have the cloud services, we have everything going in here. That is, after this, we start writing user stories, like the epics, prioritize them. We write some code. Maybe we are very happy at this time. I don't know why I put the happy face here. But then, we are happy because we are finally doing some real work. And then source control, we check in, and out here comes the pipeline. So the whole purpose of this slide is concept to cache is from here to here. So once it goes in the hands of your customer is the first time you even see money. Here you see nothing. So this is all the non-value adding waste. This is the value adding waste where you get some cache at the very end. And then concept to cache, inception to cache, feature lead time, and check-in to go live. So concept to cache is a function of check-in to go live. So once you have your pipeline ready, you're getting money at the end of it. But have a conversation with a lot of people in your company where these 3 columns are actually taking a really long time. And these are the non-value adding waste that the pipeline cannot fix. So if you're saying somebody is coming and telling you, show me the money, well, if you show them the money, that is only in your control and within the pipeline. There's a lot that happens before the pipeline. So key performance indicators are check into dev, the cycle time, check into dev, how long it takes, check into stage, and check into go live all together in one canvas. How many deploys you had on dev, stage, and production. How many failures you had due to unit tests or functional tests or performance or security vulnerabilities. And I guess this is a personal favorite. So code quality is a function of cyclomatic complexity and code duplication and unit test coverage. So it's not one. It's a triangle. And where the force is really at the center of this triangle. It's something that is not tangible. You have 3 very important things at the vertices, and then the center of gravity is where the force is. That's your code quality. Doesn't have to be exactly like this, but the idea is don't rely too heavily on any one metric, because every metric can be gamed at the end of the day, and developers are really smart. They know exactly how to game every single metric that's under the sun. So make sure you cover like this curated garden needs to be like pretty well protected. Avoid death by 1,000 test types. Don't have 108 test types that I just cannot, like I'm having to set up 3 meetings to even understand what all the test types mean. And avoid death by 1,000 environments. The fewer environments you have, the faster you will go. So show me the money isn't only what Jerry Maguire went through. I personally go through this a lot. Like, why should I spend $1 million on pipelines, right? That's not how I make money. I'm a product company. Why should I spend on the pipeline? So pipeline failures in dev, stage, production, we all talked about it, and how many number of defects actually escape the pipeline. So this is how you have to measure the return on investment of the pipeline, right? If your pipeline is actually not catching the problems, we have a bigger problem. So we spent $1 million building that pipeline. We have to always make sure that it's actually catching all the problems. So it's better to have your data so that when you go into this show me the money conversations, you're better prepared. And the product owner is never going to say, let's stop the line and build a pipeline. That's not going to happen. So we have to do it while the product is flowing through the pipeline. So imagine building a pipeline while the product is flowing through it. So it's kind of hard, but it's not entirely impossible if we have our KPIs in order. Stability index is another such function where the CG is in the middle. So checking to go live, number of defects that are escaping, customer delight is if I have repeat customers. But that's only when I know my customers are happy with me. And then business value per sprint is something you would also try and measure. It's not the number of releases you're doing per sprint. This is a common misconception that is the reflective of your speed. You may be shipping bits, but not adding any value to your business. So we are not in the business of just flying bits from point A to point B. We need to make some money. And it's definitely not the number of tests executed. 5 tests could give you way better confidence than even 500. So firmware, a quick mention. I may actually have to skip the firmware, and I'll go to Internet of Things. So for firmware, all I had was, I think I mentioned, the rate of change is higher towards the beginning. So if there's one thing to take away from this slide, it's have emulators, simulators up front, have the real devices when supply chain permits you. The suppliers are not going to take your feedback every evening and give you fresh devices next morning. That's not going to happen in our value chain anyways. So move the emulators up above. The rate of change here is probably 50 times more. Internet of Things and eggs. So continuous delivery of eggs. Like if we can be very serious, how does it work? So you had eggs, you had an egg tray. Your egg tray kind of knows that we started with 4 eggs, now I have just 1. Send a Wi-Fi signal to the grocery store and maybe your mobile phone also, and then a drone comes with 4 eggs and drops it to your home. So that's all that is there to Internet of Things. And one way or the other, it's all going to come down to eggs or something like that. If you're not turned on by eggs as much as I am, just imagine something that is your favorite thing, and then it's all going to work out. IoT, the cars, definitely. OTA, over the air, is the big thing now. So once you hit the car directly over the air with a new update, the most important thing to remember in this slide is it should self-heal if there is a problem. You don't hit, this is continuous deployment, not even delivery, right? You hit the the consumer who's driving the car at that time. If there is a failure, immunity plus is it learns to heal by itself. You cannot leave the driver of the car in danger. And this is a far bigger discussion also happening in the medical devices industry. When a doctor is in the process of doing a surgery, you know, updating some of the equipment can be very, very fatal to the patient. So probably a larger conversation for another day. Pipeline is not a pipe dream. I don't have to say it. Everybody else in this conference has already said it. It's very much a reality. But if you find yourself arguing about CI, CD, and all that, just remember the most important thing is continuous improvement. So you do one improvement at a time, and you keep going. Finally, the last slide, this is the closing. Very influenced by the recently concluded Olympics and how relay races were getting screwed up because the baton was not very easy to pass, even in an international event. And now we have dev and QA and tools and infrastructure and platform and release and InfoSec and operations trying to pass the baton. Not fun. If you've been there, like I've been there several years, it's not fun, but all we are trying to go again from left to right, and we make money only when we are at the extreme right. So Conway's law kind of touches on this, and then Maya Angelou is the last thing. Is if you heard the Olympics, the Apple ad was coming up every now and then. So I note the obvious differences between each sort and type, but we are more alike, my friends, than we are unalike. So with that, I say thank you very much. Thank you for listening, and if you have any questions, I'll be right back.